Hello friends, today we are going to talk about ping. So what is a ping, use of ping, limitations of ping, how we can use the ping smartly. So let's get started. The first, what is a ping? So ping is an acronym which is called as Packet Internet or Inter-Network Grouper. So it's just a protocol, or you can call it as a tool which is available in all the machines, right? So it is in a network administration software utility, which is used to test the reachability of host on the internet protocol network. It is also available on the, as I said, all the machines, okay, where basically it use the IT engineers who use to test the network connectivity, reachability from their machines, right? So let's see the use of ping. So, so as I said, the primary use of ping is just to test the connectivity, in the picture you can see the host from the user. You can just ping anything which is responsible to reply, or the machine who's currently live, which is up, okay, and reachable, we will respond with the reply packet. Okay, so here you can see we are pinging 10.10.100.1, and the machine is currently power on, up, and reachable, so it is replying with their packet, right? So it means machine is up and reachable. So it's a basic usage of ping. Now we can also see the limitations of the ping. So generally, the ping is in a data centers, or critical servers, like in a data center, right? In a production environment, ping of a server is getting blocked with the firewall just for security reasons. We need to block it, right? So it doesn't mean that server is unreachable, right? So now in this case, you can see we are added a firewall in between host and the machine or a server, but it's blocking the ping packet, because normally in a firewall we are just opening particular services like ATA, uh, 443, like particular ports or particular applications we opens with the firewall. So ping will not work, but still you will be able to access the server or application which is hosting on that machine, right? In that case, ping is not useful, right? Because ping is getting blocked, but still application is permitted through the firewall, and you will be able to access that machine, right? So this is the limitations, you can say, where you can't use the ping, to monitor or test, as a parameter to test the reachability of particular server, right? So this is one of the limitations, I can say. Now we can see the smart use, okay, of ping, how we can use the ping smartly, right? So just assume that here I already noted here, make sure ping or ICMP is not blocking in between the path or on devices, right? So if you know that ping is not blocking anywhere, so you can monitor your all the devices, okay, or you can just put any device where you can just permit that device to ping all your network devices, so you can just monitor that device's liveness on a single machine, or you can just use any tool, right? There are numbers of tools you can just add in your machine, and just add your all the remote machines IP address in the particular tool, or you can just monitor all the machines network status, connectivity status in a one dashboard. Okay, so that's a basic use, or you can use of that ping utility. Now second thing, how you can read that ping command, right? So here you can see we have ping that www.google.com. Okay, now it is resolving to particular IP. So there is a one use that it is resolving to a particular IP. It means there is a DNS reachability, right? So it is able to resolve that particular domain to an IP. It means we have a DNS configured properly, or the particular FQDN has entry on this DNS servers which is pointing to a particular IP. So that's a simple use which can use with the ping tool. Now, you can check the line every time you are pinging or someone is replying back, then you can see the statement, right? Reply from that particular IP, that bytes, time, and TTL. Okay, need to know what's the meaning of that particular statement, right? So reply from that IP, it means this is the IP which is replying to your request. Okay. Second thing, the bytes. Bytes, now here it is showing bytes 32. It means we are sending the traffic with the 32 bytes of data with each ping packet, which we can modify, which we can add more and more bytes to the data. Now, that is a part of troubleshooting or, advanced tool mechanism, we can say, where we can use that. Okay. But this is a simple meaning that here it is adding a 32 byte. Now it is a window specific, which is adding 32 bytes. Now it comes to the Cisco, which is adding 100 bytes by default. Okay. Now, but it means it is going with the 32 bytes of data with that packet. Now the time which is showing here, now I have pointed at 21 ms, so it's a 21 milliseconds, right? So to reply from the server back to my machine, it took 21 millisecond, right? So in that particular time, okay, how much time it takes, to uh, reverse the request and response time, how much time it takes. So that is the time which is called as packet round trip time. Okay, so with this time you can monitor what is the latency, right? How much time it takes to reach the server, right? So on this basis you can if there is something slowness is going on your network, you can just ping and you can just check whether the time is less or time is more, right? More time means there's a higher latency. It means to say it will take time to load the application in your machine, in your browser, right? So that is a way you can troubleshoot, right? Now there's a TTL. So TTL is basically it's a time to live, right? So each ICMP packet which is used for which just comes with the TTL value, particular TTL value. Now TTL value decides by the remote uh, server or remote machine to whom you are pinging. Suppose you are pinging a router, okay, you are pinging a switch, you are pinging a machine, okay. So in the every particular machine, they have a particular OS, right? Some have Windows OS, some has Linux, okay. In some machines has Catalyst, Cisco switches, and a Palo Alto firewall having a PAN OS, right? So every OS has particular, static TTL values are already configured, okay, in that OS, right? It starts with the 32, 64, 128, and 255. Okay, so now here we are pinging, and if we are getting a TTL value as a 55, it means the remote machine, whatever the remote machine is, okay, which TTL value is a 64. Now it is decremented by 9 hops, okay, so that's why it is showing as a 55, right? It means uh, every L3 device, okay, in a return traffic, it decrements by 1 TTL value, okay. So like say here google.com, which is having a TTL value of 64, okay, and when you are pinging in a return path, it's decrementing 1 hop at each L3 device, like a router, a firewall, or anything which is a L3 device, is decrementing by 1 at every L3 device. It means from your machine to the Google server, we have 9 hops in between. So after that 9 hops cross, so it decrement by 9. So 64 minus 9 is equal to 55. So that it says is a TTL is a 55. So basically this is, we can use in a testing of your production environment, where you can see what is the TTL value, what was yesterday, what was today, right? So whether the path has changed or not, right? Whether it is showing the same path, or if someone has added more devices or remove the devices, the TTL value gets changed, right? So you need to focus on that. Now the uh, you can identify, right, the device, as I said before. Okay, it's a remote device having an OS. Okay, so there are some fixed TTL values are already configured in that particular OS, like Unix having 64, Windows having 128, and Solaris 254. Now these TTL values can be vary based on the particular OS. Even though in a Windows also there are 64-bit, 32-bit, or there are some latest Windows 8, Windows 9, 11. So they may get changed, but once it's configured, once there is server who having some TTL value as 128, that remains same, right? As a 128, unless the server gets changed, right? So you can easily able to identify. You can also identify if we have a router or a switch, okay, who has some static TTL values. Okay, so basis on that TTL values, you can identify whatever you are pinging, it is a router or a switch, right? So once you identify this particular IP is belong to router, and someone remove the cable and connect to the switch and configure the same IP on the switch, but next time when you ping, even though if you are getting a reply from the same IP, but the TTL value has changed, you can easily identify that the IP is currently not on my particular router device, right? So this is the way you can identify. Okay, now here is the thing. You can see like here I'm pinging that 4.2.2. Now here I'm getting TTL value as a 52, right? But I'm pinging my own router, which is 192.168.0.1, that is replying with the TTL value as 64. Now the 64 is basically is a directly connected, right? So my IP is belongs to 192.168.0. Subnet. Okay, so it is directly connected to me, so there is no L3 device in between, right, me and my router, right? My router is a first L3 device, right? So I am getting a TTL value 64 directly, but the 4.2.2 is Google DNS server, right? So which is almost 13 hops away, okay, or say 12 hops away from me. So that is why it is reducing. 64 minus 12, I'm getting a 52, right? This is a TTL value which I'm getting for 4.2, right? But now you can see the C-scope. I ping to the C-scope, it's resolving the particular IP, but I'm getting a TTL value as a 236. It's meaning that whatever the C-scope is currently hosting this website, or where this IP terminating, that having the TTL value as a 255, right? So after reducing those hops, okay, so you can see 236 hops, it means there are uh, almost 17 19 hops, right? So in between Cisco and my machine. So after reducing that, I am getting the TTL value as a 236, right? So this is the normal TTL. Okay, now TTL is very different compared to the ping and compared to the DNS. We will talk about that later. But the TTL in the form of ping, okay, it is the value which is statically already configured in the machine OS, okay, and which gets decrement by 1 in every L3 device in between in a return path towards the host. Okay, next. Now you have understood, right, that uh, ping is a very simple tool, okay, which we can use to just to verify whether the link is up or down, right? You can just check the latency, how much latency you are getting, right? What is the TTL value, right? The device which you are pinging, which is OS that device have installed in that device, right? So this is a basic tool which we can use as a ping, right? Also we check that limitations, okay, if there is a firewall and ping is normally ping is getting blocked in the firewall, so you will not able to ping that address, but it doesn't mean that that server is down and application down, right? Only ping is blocked, not the application, right? So there is a limitation. Okay, and the drawbacks uh, of this ping is like uh, if you use that ping, you can use the ping for um, bandwidth testing. You can generate a more and more traffic towards ping by adding a multiple load. Like we say, we by default is adding a 32 bytes in a Windows machine, 100 bytes in a Cisco, but you can add more and more. You can add up to 65,000 of bytes of load while pinging to the destination server, right? But if you are adding more and more uh, load on the ping request, you are unnecessarily utilizing a bandwidth. Or if any user or any tester or who just want to break down your network, who can use that ping tool, okay, and just choke down your ISP's bandwidth, who can use it ping. So that's why normally we block that ping in a production environment, right? Also, we check that how we can use it smartly, right? So there are numbers of uses, right, where you can use it smartly. There are also numbers of smart uses where you can use for to test the fragmentation of traffic. You can use test your bandwidth. If ISP allocated a bandwidth and you want to test it whether you are getting that whatever the bandwidth as a provider says, and it is really we are getting or not. Okay. In an internet scenario, we have online tool, right, where we can just go on site and test it whether we are getting upload download speed properly or not. But what if we have a MPLS link, right? What if we have a P2P link, right, which is a private link, right? So there are other tools as well, but only with the ping we can test it by adding a load onto a particular load, and we can test it, right? So this is a very simple definition, simple usage I have described about the ping. Okay. If you think, if you gain some knowledge from this video, you can just like and subscribe to my channel to get more videos on this topic. Thank you.